Hi everyone. I wanted to take just a couple of minutes to show you the next step in the completing the square process that we started yesterday. So yesterday we worked really hard on actually completing the square, but now I want to talk about what to do with it once you get your answer in that form, how that helps you learn about the quadratic equation you're looking at. If you are feeling confident about the completing the square problems you did last night for homework, I suggest that as part of your assignment for tonight, and we'll talk about the other part later, but as part of your assignment for tonight, I suggest you go through and finish it up, meaning you go back to each one and graph it using the vertex and the zeros, which is what we're going to talk about today. If you are not feeling super confident about the completing the square, you don't have to do that step yet, but just understand that that's going to double up homework for you next week. So I think tonight is a perfect night to do it because your other assignment's going to be pretty short. So I suggest it, but again, if you need some extra time into next week to get that done, you may. Okay, so I'm going to start with one example, and the very first thing I want to do is just run through that completing the square process again. So here I have a quadratic equation. I want to turn this into vertex form, meaning I'm going to have to complete the square. And the completing the square process starts by moving some numbers out of the way that we don't really need there, that we don't really want there even. So I'm going to start with this negative 30. I want to shift that over to the other side because I would rather replace it with a number that lets me make a perfect square. So I would write this as y plus 30 on the other side. And then I also want to get rid of this 2 because in order to work with a perfect square trinomial, I really want no leading coefficient. So I'm going to factor out that 2, meaning I'm going to put the 2 out here, and then inside here I'd be left with an x squared, and this would turn into a 2x because I'm factoring out the 2. So x squared plus 2x. You should see at this point, by the way, that now if I distributed that 2 back in, it would turn back into 2x squared plus 4x. And remember, we moved that 30 out of the way. And so now what I really need here is a magic number. Okay, that's going to give me a perfect square. Well, to get that magic number, we want to take this middle number of the soon-to-be trinomial, cut it in half, so we're going to do 2 divided by 2, and get 1. And then we're going to take that 1 and square it, and that's the number that goes right here. So 1 squared is 1. That's the magic number that I'm adding in there. However, I can't just go around adding random numbers to my problem, right? So whatever I do to the right over here, I also have to do to the left. And the thing you have to consider here is that I didn't really just add a 1, okay? I actually added this 1 multiplied by the 2, so over on the other side, I want to add a positive 2, okay? So now my equation looks like y plus 32 equals 2 times x squared plus 2x plus 1. Whoops, that's a very sloppy x. And then this is a perfect square trinomial that I could write as a binomial squared, okay? Because if you notice, if I take the number 1, which was sort of my middle step back here, if I double 1, I get this, and if I square 1, I get this. And that's always sort of that relationship that we see. So I would write my final answer as y plus 32 equals 2 times parentheses x plus 1 squared. So that was the completing the square process that we learned yesterday. Just a quick recap of what we did. Now we're going to talk about what to do with that. Okay, so the next layer I'm going to toss on here is now taking this equation that we just came up with, so I'm picking up right where I left off, this is the equation I just had, and using it to find the actual vertex. And if you remember, what we just did, this equation right now, is written in vertex form, which really looks like this. Y minus k equals a times x minus h squared. So again, that right there is vertex form. And it's called vertex form because the vertex is sitting right there for you. Vertex is always represented by the letters H and K. You probably remember that from last year. So if I did all of this work, the whole reason I would do that is to be able to say, look at my equation, now I can just pull H and K out of it and I know where the vertex is. Okay? Now, what I want you to notice here is that H and K in the formula, so this in red here is the formula, H and K are both negative in the formula. But you'll notice that in my specific example, both of these numbers are positive. The reason these came out to be positive is because these numbers must have been negative to begin with. For example, if you put a negative 5 in here for H, you would end up with x minus negative 5, and then that would end up looking like x plus 5. So anytime you pull this H and this K out of the equation, you need to think about what the sign actually is. It's always going to be the opposite of what it looks like because there were negative signs in the original formula. So that means looking at this right here, that tells me that my H value is really a negative 1. And looking at this right here, my K value is a negative 32. And so then my vertex is simply negative 1, comma, negative 32. And that's really all there is to that. Getting it into vertex form is the hard part. The only other step you have to do from there is pull H and K out. And I would say the negative sign is the only thing I see people really mix up here. Okay, so just remember that if it looks positive, it's really a negative number in disguise. Okay, so there's my vertex. Onward. The other thing you can do from this form is calculate the roots. Now, if that's sounding familiar to you, you do already know a method of calculating the roots. You can calculate the roots from standard form using the quadratic formula. Okay, and you've done that 1,000 times. So that is a possibility. If I just say find the roots, I don't care what method you use. This works just as well. This method that I'm about to show you will work if your equation is written like this. Now you might be thinking, couldn't I just convert that to standard form and then use quadratic formula? Sure. You know, I'm hoping you'll think this is easier than doing that conversion. Now, if you're a little more clever, you may be thinking, hey, wasn't this in standard form back when we started? Yes, it absolutely was. Okay, so if you really did want to use quadratic formula to find the roots, you could. I do believe there is one question on your test, though, where you have to do it from this form. Okay, so you do have to know this method. It's not like it's difficult. And then also, if you're just presented an equation that's in vertex form opposed to standard form, this might be easier or at least less time consuming than converting to standard and then doing quadratic formula. So, bearing all of that in mind, here we go. So, when I'm talking about roots, I'm really talking about x-intercepts. Okay, I'm looking for the x-intercepts of this graph. And at the x-intercept of anything, anytime I ask you that question, what do you know at the x-intercept? You always know that y equals 0. So if I'm looking for the x-intercept, really of any kind of graph, I can plug in a 0 for y. All right, that's a place to start. So I'm going to make this a 0 plus 32 equals 2 times x plus 1 squared. And then, of course, you don't really need the 0 here, right? Once I plug that 0 in, it's really just a 32. So I have 32 equals 2 times x plus 1 squared. I know some of you are dying right now to expand this and simplify it and distribute the 2 and da-da-da-da. Remember, if you do that, really what you're doing is converting it back to standard form, which takes us back down the quadratic formula path. This is an alternative to that. So think about not simplifying over here, but trying to get that x by itself, solving it, right? I can solve it by getting rid of this 2, and that 2 I can get rid of with division, which means I can divide over here. So 32 divided by 2 is going to leave me with 16 over here on the left. This 2 is gone now, so now I have x plus 1 squared. And then you should know what to do from here. Now I'm trying to get that x plus 1 out of the parentheses, so I need to get rid of the square. I'm going to do that by taking a square root. But this right here is the step that is sort of critical. okay? When you take a square root of a number in an equation sense like this, remember that there are two possible answers. So the square root of 16 could be 4. It also could be negative 4. Okay, so square root of 16 could be either one of these. And this is the step you have to make your split in. And you'll see what I'm talking about in just a minute. Now what I can do is square root of x plus 1 squared over here is going to leave me with an x plus 1. So I'm going to have 4 equals x plus 1 and negative 4 equals x plus 1. So I did the square root of 16, got my two square root of 16, got my two different answers. Square root over here really just cancels out the square, and I'm left with these parentheses, but I need to set this up as two separate equations. I could have x plus 1 equal to 4. I could have x plus 1 equal to negative 4. Okay? And I do have to solve these separately. And this shouldn't be stressful to solve this, right? If 4 equals x plus 1, subtract 1 on each side, and I get x equals 3. Or if negative 4 equals x plus 1, subtract 1 on each side, and I get negative 5. Okay? And so those would be my two roots. Let me show you the mistake I see most frequently. Okay, and this is sort of what I was talking about. I have a lot of people who forget this right here, this step that I pointed out, where you take the 16 and make it a 4 and a negative 4. They just do this left side. They just say, okay, the square root of 16 is 4, so x plus 1 equals 4, and they get 3. And then they say to themselves, well, but I know I'm supposed to have two answers, so they just throw a plus or minus in front of it. Okay? You can't do that. Don't do what I just said. Okay? Because you do get two different answers when you're solving a problem like this. So you have to make the split, and that's why I made such a big deal back here. You have to make a split at this point right here. You have to set up two separate equations and solve them separately and get two different answers. Okay? So it's not enough to just do it with the positive version and then throw a plus or minus in front. Okay? So again, my roots there should have been the x equals 3 and x equals negative 5. So then just to kind of recap everything that we just talked about. We were able to complete the square and get our equation written in vertex form. Here in green is what we came up with. Y plus 32 equals 2 times x plus 1 squared. We did that with completing the square. Then we were able to come up with the vertex, and that was easy. We just pulled that right out of vertex form, and we got that the vertex was at negative 1 comma negative 32. And then we did some equation solving trickery, and we got that we have roots at x equals 3 and x equals negative 5. And so here's what all of this information lets us do. If we now wanted to take this thing and throw it on a quick graph, we could. We could say, well, let's see. Let me number a little bit here. I know that I'm going to have roots at x equals 3 and x equals, of course I didn't go all the way to negative 5, and x equals negative 5. Okay? And then the vertex, and this of course I didn't make super friendly, at negative 1 comma negative 32. Let me just shift that up for a second. The vertex would be, so here's negative 1, and then negative 32 would be, you know, way the heck down here. Further than that, really, but we'll just say that's negative 1, negative 32. And then using those 3 points, the two zeros, which are in red, and then the vertex, which is in blue, I could actually sketch this parabola. Okay? And so that's kind of your end goal, and that's what the rest of that worksheet was having you do, is use the vertex form to get the roots, to get the vertex, and then draw a graph. Okay? And they're not always going to be super pretty. Sometimes you're going to have decimals that you have to approximate, whatever. These are kind of the key points here, here, and here that you would need to graph a parabola. Okay? So again, if you feel okay about that stuff, if you feel okay about the completing the square, you feel okay about what we just talked about, go ahead and do the rest of that assignment tonight, along with the quadratic formula stuff, which you're about to learn. If you are still feeling shaky on completing the square, it is okay with me if you wait. It's just going to make you double up on homework sometime next week. Okay, hope you guys have a great weekend.